Good morning, everybody. My name is Maurel Dzifack Kenfack. I'm a PhD student at the University of Maurel. I would first of all like to. The University of Maurel is in Cameroon. The Cameroon is located in Central Africa. I would first of all like to thank the organizer of this annual and hybrid event that's going to be taking place at the end of this month and at the beginning of the month of December. I would like to thank you for giving us the opportunity to share our experience and also to share our works with the research community. I would also like to thank our main focal point, the Professor John Conradi, who is actually at the Free State University of South Africa, for giving us the opportunity to use the resources of the Center for High Performance Computing for our calculation, for our different calculation in our investigation, in our research. My main topic in my research was optoelectrical and optoelectrical, electronic and thermodynamic DFT study of cystocoparaphénylene and its derivative for improvement of organic solar cell efficiency. So during my research, I wanted to first of all improve the performance of organic solar cells, and one of the main challenges that I had to overcome was to seeking new challenging materials that can overcome the current use materials or the classical use material in traditional organic solar cell architecture. So the main challenge was to seek a new material that can challenge them and which property can be also more appropriate or more amazing than the traditional materials. So during my research, as I was going through the document, the books, publication and articles, I was amazed by the property of carbon nanotube. So I could not first of all take those properties because there are some properties that was not I couldn't find in those documents. So it was up to me to calculate those properties. That is why I first of all isolated the crystal structure of a carbon nanotube sample. I isolated it in a computational environment using Mercury program, and thanks to our collaboration with the Free State University of South Africa, who granted us the CHPC resources, I was able to use the Gaussian 16 suite of programs, a very powerful program, to launch many of my calculations. So the very challenging effort that I had to do at the beginning was to look for the appropriate method that I can use for those calculations. So I went for a DFT study, a density functional theory study, and also I was called to use some functional. When I was about to choose some functional, there were Betralib functional and APFD, that is Ostenfrich and Peterson functional, and I was also using the Grimm dispersion. So I launched my calculation by the methods of launching my calculation was by using Gaussian codes. Gaussian codes allows you to initiate your calculation, and at the end of my calculation I was able to calculate some properties like electron affinity, potential ionization, and also band gap, excitant binding energy, HOMO and LOMO level. And at the end of my calculation, the result that I obtained was very amazing. I was also able to calculate the polarizability, hyperpolarizability, first order hyperpolarizability. That gave me very amazing results for a carbon nanotube that I use. And at the end of my study, I was able to say that the carbon nanotube can be used as a candidate for organic solar cells. I would like also to thank you because that work, the CSPC resources give me the opportunity to publish my work, and my work was accepted by the Journal of Molecular Modeling. Thank you very much, and thank you.